क्या आप जानते हैं कि भविष्य में ऊर्जा का स्रोत क्या है?
You know what is the future energy source? Hydrogen is a future energy source presented by engineer Ankit Kesarwani. If you are not subscribed my channel, firstly subscribe my channel Genius Zone and gets more updates. Contents Introduction History Methods of producing hydrogen Possibility of hydrogen source What is fuel cell? Forming of electrical energy Advantages versus fossil fuel Disadvantage Utilization of hydrogen gas Present use of H-fuel hydrogen technology Development in India Conclusion Gaseous hydrogen is 14 times lighter than air, colorless, odorless, tasteless and reactive gaseous element. Most attractive features of hydrogen as an energy carrier is that it can be produced from water which is abundantly available in nature. Hydrogen has the highest energy content per unit of mass of any chemical fuel. Its burning process is non-polluting, hence, use in fuel cells to produce electricity and useful heat. Its heating value of 28,000 kilocalories/kg is almost 3 times that of hydrocarbons fuels. History: NASA has used liquid hydrogen since the 1970s to propel the Space Shuttle and other rockets into orbit. The earliest application of liquid hydrogen fuel is expected to be in a jet aircraft. This possibility was demonstrated in a subsonic aircraft in 1957. Methods of producing hydrogen. Hydrogen is a secondary fuel that is produced by utilizing energy from a primary source to break the chemical bonds to release hydrogen. 1. Electrical energy, 2. Heat energy, 3. Fossil fuels, 4. Solar energy. Electrolytic hydrogen production. The process of splitting water into hydrogen and oxygen by means of a direct electric current is known as electrolysis. Principle: an electrolysis cell consists of 2 electrodes, metal or carbon plates, immersed in an electrolyte solution. A DC voltage is connected to the electrodes so that an electric current flows through the electrolyte solution. As a result, the water in the electrolyte solution is decomposed into hydrogen gas, H2, at the cathode and oxygen gas released at the anode. Simple electrolytic cell. Ideally, a voltage of 1.23 volts should sufficient for the electrolysis of water at normal temperature and pressure. Second, thermochemical methods. A higher conversion efficiency might be possible if the heat produced by the primary fuel could be used directly to decompose water. Such direct decomposition into hydrogen and oxygen is possible, but it requires a temperature of at least 2500 degrees Celsius. Because of the temperature limitations, direct single-step water decomposition cannot be achieved. However, a sequential chemical reaction series can be devised in which hydrogen and oxygen are produced. In this operation, energy is supplied as heat at one or more chemical stages and water is consumed and all other chemical intermediates are recycled. Third, fossil fuel methods. A gaseous mixture of carbon monoxide, CO, and hydrogen is formed in the first stage, in the production of hydrogen by using a fossil fuel, that is natural gas, petroleum product, or coal. To remove the carbon monoxide, the mixture is submitted to the water-gas shift reaction with steam. The carbon monoxide is thereby converted into carbon dioxide with the formation of additional hydrogen. The carbon dioxide is an acid gas that can be absorbed in an alkaline medium. Fourth, solar energy method. 2 approaches are under consideration. First, biophotolysis. The oxygen is evolved from the green plant, but the hydrogen ions and electrons are removed by interaction with carbon dioxide from the air to produce simple sugars. Certain single-cell green algae are able to make the enzyme, that is biological catalyst, hydrogenizes. The hydrogen ions and electrons combine in the presence of hydrogenizes to form hydrogen gas. Second, photoelectrolysis. Research is being directed at increasing this efficiency by selection of electrode materials, electrolyte solution and electrode catalysts. The efficiency for the conversion of solar energy into hydrogen, oxygen energy has been very low. A current is generated by exposing one or both electrodes to sunlight. Hydrogen and oxygen gases are liberated at the respective electrodes by the decomposition of water. Possibility of hydrogen storage, compressed gas storage. Hydrogen is conveniently stored for many applications in high-pressure cylinders. Liquid storage. Practical approaches to store the hydrogen as liquid at low temperature at -253 degrees Celsius or below. Line packing. The use of the line pack storage provides a reliability small capacity storage system, but a very fast response or hour-by-hour variations in demands. Underground storage. This is the cheapest way to store large amounts of hydrogen for subsequent distribution would probably be in underground facilities. Metal hydrides. A number of metals and alloys form solid compounds, called metal hydrides. By direct reaction with hydrogen gas can be stored. What is a fuel cell? A fuel cell is an electrochemical device that combines hydrogen and oxygen to produce electricity, with water and heat as its byproduct. 2.8 kWh of electrical energy should produce by 1 cubic meter of hydrogen gas. Forming of electrical energy. Hydrogen fuel cells utilize the energy of a reaction between hydrogen and oxygen, which is converted directly and continuously into electrical energy, like a refuelable battery, for electric vehicle propulsion. Advantages versus fossil fuel. Engines using hydrogen will last much longer and start faster in any weather. Hydrogen is the only fuel whose production and end user can both contribute directly to eliminating many of our environmental, economic, and health problems. Hydrogen can also be transported, like electricity, to locations where it is needed. Storage of energy as hydrogen seems relatively easy than the electricity. Disadvantage. Liquid oxygen could also be formed from the air present in an empty tank or pipe when it is filled with liquid hydrogen. Hydrogen is a highly flammable gas, cost of production and cost of storage. For hydrogen to be in a full liquid state, it needs to be cooled to 20.28 K, -423.17 degrees Fahrenheit / -252.87 degrees Celsius. Utilization of hydrogen gas, 1 for residential uses, 2 for industrial uses, 3 for as an alternative transport fuel, 4 for as an alternative fuel for aircraft, 5 electric power generation. Present use of hydrogen fuel. The largest user of hydrogen is the petroleum industry for converting crude oil into gasoline and hundreds of chemicals. Sometimes used in welding torches for welding or cutting metals. Hydrogen technology development in India. The Department of Non-Conventional Energy Sources, DNS, Ministry of Energy. India has so far supported 22 research and development projects of repute and universities in various aspects of hydrogen technology, namely, production of hydrogen by photoelectrolysis of water using solar energy, production of hydrogen by blue-green algae and by certain bacterial species, storage of hydrogen through metal hydrides, problems relating to utilization of hydrogen as a fuel, liquid hydrogen production, storage and utilization, etc. Conclusion: using small portion of the global land area, we can manufacture enough solar hydrogen to supply the entire energy requirement of the planet. Solar hydrogen could make entire nations fuel independent and pollution free for as long as there is sunshine and water. Thank you.